Hi geometry students, welcome to your video on special right triangles. So we learned a little bit about the Pythagorean Theorem, which we learned we can only use with right triangles. So we're continuing on the same theme, right triangles, and these are special ones. There are two of them. There are two, and they do indeed come up all the time. In fact, when we look at trigonometry, which sounds scary, but it's not, you will see that these special right triangles can be utilized to figure out trigonometry ratios. Okay, so what are we talking about here? Well, first of all, we know about right triangles. We know that they have certain properties already, but these are specific ones that have properties that let you use shortcuts to determine side lengths without needing to use the Pythagorean theorem. So the first one is called a 45, 45, 90 triangle. Both the legs are congruent, and the length of the hypotenuse is root 2 times the length of a leg. So here's your 45, 45, 90 triangle. It's an isosceles right triangle. So these two angles will always be 45 and then of course 90 for the right angle. The legs are always the same length because that's part of the definition of an isosceles triangle. We learned that the two base angles are congruent and the two opposite sides to the base angles are congruent. When you want to find the length of the hypotenuse of a 45, 45, 90 triangle, all you have to do is multiply the leg of the triangle, if you know it, times the square root of 2. You can find the leg by working backwards from the hypotenuse, and we'll see a problem like that later on. In a 30, 60, 90 triangle, the other type, the length of the hypotenuse is twice the length of the shorter leg. So your shorter leg, hypotenuse is 2 times as long. And the length of the longer leg is square root of 3 times the length of the shorter leg. So shorter leg times root 3. So again, if you know the shorter leg, you can find these other distances. But if you know one of the other ones, you can find the leg, that shorter leg of the triangle as well. So let's look at why these are special triangles. Why does this work this way? And we'll start with the 45, 45, 90 triangle. So we're going to use the Pythagorean Theorem, which is a squared plus b squared equals c squared. We know a and b are the legs of the triangle. So this is s squared plus s squared to equal the hypotenuse squared. And we want to prove that equals s root 2. That's what we're trying to show that. We're trying to prove that. So how many s squared do I have? I have 2. 2s squared. And if I was solving for c, I would take the square root of c squared. And when I draw my square root signs, I like to draw my square root signs so that it crosses out the exponent 2. Helps me remember, oh, that's just c. And we do indeed get s because the square root of s squared is s. But the square root of 2, that I cannot take because 2 is not a perfect square. So s times the square root of 2 is the value of c. And there you have it. So I can show you that no matter what the value of s is, the hypotenuse on this triangle will always be s times the square root of 2. But what about the 30, 60, 90 triangle? Well, the first thing I want you to notice is that I do not have a single 30, 60, 90 triangle. I have 2. And I also have another special triangle. It's not a special right triangle. It's just a special triangle because it's equilateral. Notice that is an equilateral triangle. How do I know it's equilateral? Equilateral because it's equiangular. What do you think that means? Angular. Equiangular, all 3 of these angles, the whole thing, not just that half that's marked 30, all 3 of those are 60 degrees. So, on this equilateral triangle, if I know that this is equilateral, I can say that this s, well, this is the same here. Because in an equilateral triangle, when you drop an altitude to that equilateral triangle, it automatically bisects this side that it comes down to. And it's an altitude because it makes a right angle. So I know these two individual lengths are equal, which means because this is an equilateral triangle, that this whole side, which has a value, if you look at this right here, you add those together, that's 2s. That means that this side is 2s. Ta-da! Twice as long as the shorter side of the triangle. So that proves part of our equilateral triangle. Let's use the Pythagorean theorem to do the rest of it. Let me switch colors. We'll use red. So a squared plus b squared equals c squared. Well, let's see. We have s for one of the legs. We don't know the other leg, so I'm going to leave it b, and that's what we're going to solve for. And we have 2s for the length of the hypotenuse. Notice the parentheses around the 2s, y'all. Make sure you put parentheses around it because you're squaring the entire value of that side, not just that variable. So now I have s squared plus b squared equals 4s squared, because that's what I get when I multiply 2s times 2s. So I'm going to subtract s squared from each side because I'm solving for b here. I want to show that it's equal. What's it going to be equal to? This is going to be s root 3. That's what we need to show. So when I subtract that s squared, I get b squared equals 3s squared, square root, b equals, well, that's the square root of 3, which is going to be root 3, and the square root of s squared, which is going to be s. So the square root of s squared, s. I can't take the square root of 3, and lo and behold, there it is, s root 3. S root 3. So now I've shown you why these special right triangles work. Let's put them into action by solving some problems. Okay, so here you have a 45, 45, 90. Look back in your notes. The legs are equal. Notice that this leg is not labeled, so we're not finding that. What is going to be the value of x? Well, it's 8, the length of the leg, times the square root of 2. That's it. That's the whole process, guys. That's it. How about this one? On this one, you get the hypotenuse, which is 3 root 2. So to figure out what the hypotenuse, or go from the hypotenuse to the leg, you're going to divide 3 root 2 divided by root 2. They're going to cancel out, and the value of x on this one is just 3. Now, I know you're thinking, can't I just take off the root 2? Sure, but I don't want you to think, quote, take off, unquote. We're dividing. We're dividing. We're going backwards from what we learned will give us the hypotenuse, so we're dividing it off to find the leg. Here's another 45, 45, 90 triangle. Now I know it's 45, 45, 90 because this is a square. I can see my 4 right angles and 4 equal sides. So I know that once we draw this diagonal right here, that it bisects those angles. So this is 45, 45, 90, which means x has a value of 18 times the square root of 2. All right, how about this one? This one, I have the leg, it's 6 root 18, and it's 45, 45, 90, so I'm multiplying that by the square root of 2. Now be careful. You're going to have to go back and think about your Algebra 1 skills. Kindly ask your teachers to review some of this radical math that you haven't seen since last year, or maybe a while back if this is if it's been a while since you saw the Algebra 1 stuff. So 6 times the square root of 18 times the square root of 2 is the same as 6 times the square root of 18 times 2 together. They're the same thing. They're both radicals, so you can put them together. That's 6 square root 36, which is 6 times 6, because the square root of 36 is 6. And the value of x on this problem is 36. Moving on to 30, 60, 90 triangles. Okay, so shortest side, that's 8. Second leg, that's going to be shortest side times square root 3. Hypotenuse is shortest side times 2. So x is 8 root 3 and y is 16. On this one, we have the hypotenuse. So hypotenuse to shortest side, we have to divide by 2, cut it in half. And remember, in algebra and geometry, we leave our fractions improper. We don't want a decimal on this. 11 halves is fine. For y, we multiply shortest side times the square root of 3. Now remember, the square root of 3, if you think of it as a fraction, is like saying square root of 3 over 1. So I can multiply the top of those, the top of the two fractions times the bottoms of the two fractions. So y ends up equaling 11 root 3 over 2. Last two problems. Okay, this time we have the longer leg, and it's a whole number. It doesn't have a radical in it. So in order to go from longer leg to shorter leg, we're going to take that longer leg and divide by the square root of 3. Because if shorter leg to longer leg is multiplied to get that value, multiply by root 3, to go the other way we have to divide by root 3. Now you should recognize that we can't leave our answer like this. We have to rationalize our denominator. We can't leave that square root of 3 in the denominator. So in order to rationalize that denominator, we're going to multiply by the square root of 3 over the square root of 3. We're going to get 15 root 3 over, remember, radical times itself. Just quick recap. Well, that would be root 9, but you don't need root 9. Root 9 is just 3. So radical times itself is just the number without the radical sign. Hopefully you notice there's one more thing we can do. 15 and 3 are both divisible by 3. So this answer ends up being 5 square root of 3. Okay, so that is the shorter leg. Well, in order to find y, actually that's going to be pretty easy because we want to find the longer leg, which is going to be found by multiplying shorter leg times 2. And remember that the 2 is not a radical. So the 2 is going to multiply by the 5, and we're going to get 10 root 3. So 5 root 3 for x, 10 root 3 for y. Last problem. Again, we have a special triangle. It's a 45, 45, 90 triangle. But they gave us the hypotenuse. So we're going to take that hypotenuse, and in order to find both of the legs, because they are the same, we're going to divide the hypotenuse divided by, that's right, I heard someone say it, square root 2. Now we're going to have to rationalize that denominator, just like we did the previous problem. Come back over here just for a second. Why did I multiply by this? Well, because the value there, anything over itself, that value is actually just the value 1. That's a 1. And multiplying by 1 doesn't change the value of a number. So I'm going to multiply by root 2 over root 2, same thing, also equal to 1, and then I'm going to simplify it. So I'm going to have 28 square root 2 over 2. 2 does go into 28, 14 times. Both of the two legs on this last triangle have a length of 14 root 2. Hope you're enjoying your geometry videos, and I will see you guys in class.